Hey guys, and welcome to one more episode of Builder Nation. For today's agenda, we have James Hedrick, co-founder and chief product officer of Azul 3D, a leading-edge 3D printing company transforming manufacturing. So welcome, James. Super happy to have you here today.
Yeah, we can start really early on. I think going back to high school, middle school, all those stuff, I was always the guy that loved to do math, science, engineering, try to build stuff. When I was 14, I built my own human centrifuge. I thought the ones you see like in the space movies of the training where we made one with a 10-foot arm out of a treadmill, building these, like those were the things I did for fun just as like a kid. So like engineering just kind of was naturally what I'd drawn into.
I mean, I did a little bit of research and I found out that you built up your own company at 16 or something like that.
Yeah, that was a funny story. So when I was 16, I started my first company, and I'll go company in quotes because it was a two-person operation. It was just my family, me and my brother setting this up, but it was doing custom lapel pins. It was this really niche market. But it was a very strong market that was good enough to be able to build up and be this combination of not too much of a time sink, but at the same time grow to a scale that really could actually help me pay for college and get through that. It's one of those weird things that just randomly you find out about and then kind of get sucked into, and never thought it would be something I would do. And even looking back 10 years later now, or even 15 years later now, I would have still never guessed that I would have got sucked into doing that of all things.
Wow. And you never continued with that, like it ended up and then you just jumped into the next thing.
Yeah, it was something where it was great for during undergrad because it was perfectly timing of you were working with manufacturers in China. So you're doing calls at 2 a.m. So you finish your homework and then you jump on a call and then you get that set up. But then once I finished undergrad, when I really decided, that was not something that was going to become a billion-dollar company. That was something that was going to be a lifestyle company where, you could very much make a salary off of it, but you kind of would stop there. And it was kind of it lost its edge, it lost its appeal. And when I was starting to graduate college, that's when I was really kind of making this transition of what do I really want to do for a career? What do I want to do next? Okay. The true answer is I had no clue what I wanted to do next. So I decided to do more school. And that's where, luckily enough, that actually is what led me into starting my next company, which is what I'm still in today.
Before starting your own company, you did some research on some pills or something like that for cancer?
Oh, yeah. So I jumped around a lot during my undergrad and my PhD. I probably worked think of top 5 or 6 different groups with 5 or 6 different distinct projects. So most of my undergrad research was in doing drug delivery for cancer and looking at how do you make different systems that could do better, like long-term delivery and targeted delivery. And that was exciting for me. I really love the technology. I love the groups. I hated the time cycles of it. One of the hard things with it is that, to get a drug that's FDA approved and build that up, you're talking about over a decade of setting that up, getting it going. And when you're 20, you're like, this is half your lifetime going toward equivalent. It's just daunting. And as I kind of started jumping through, I even when I started, after going to undergrad, I thought I was going to still do like cancer research, drug delivery, research in that drug delivery area, and joined a group that actually was pretty world renowned at Northwestern University to do it. The exciting thing about that group was it was a group of 70 people with 5 distinct different topic areas, all under the theme of nanotechnology. Wow. So I joined the group with that idea in mind, and then quickly ended up in a subgroup that was not anything related to that. It was called photolithography, which probably never heard of. But if you just break it down, photo, think about image taking, or do an image, and then lithography is patterning. So using light to pattern is the concept. And so if you think about your computer chips, this is how they're made. And so the idea was, can you be able to make write things onto chips that were as small as possible? And can we use more interesting things instead of traditional gold and silver? Like think about your conditional circuit. Could you actually be patterning proteins on the surface? So then you could be putting cells wherever you want to make your own like network in that sense. That's kind of where my PhD started. And then it rapidly jumped further and further down this rabbit hole of ultimately leading me to, okay, this 2D technology of patterning is really cool, but what if we made the world's smallest 3D printer instead? And so the goal was to make a nano 3D printer where the resolution, these parts would be 1,000th the thickness of a hair for the individual lines and dots that ultimately build up to a 3D structure. And funny enough, we could even go further to a year into that project, we realized all this work we developed and we got some really interesting results actually would work really better if we ripped out all these fancy optics, everything that we've been working on, except for this interface that was between the light sources and the part that was getting made, and actually see, could we use an off-the-shelf projector with that? And what we found out is that if you do that, you actually get the fastest printer in the world that's ever been made for 3D printing, and go to traditional 3D printing, what you talked about today. So this is this weird cycle from going from drug delivery to nano 3D printing to macro printing that I would have never guessed when I started at Northwestern University, that I would have been started with the first group, let alone end up where I did. But it was, I will say, it's a lot more fun when you can actually see objects come out with your own eyes than you have to print something for a couple of hours, put it under a microscope, stare in it. I still have these bags from all my hours under a microscope that I'll never get rid of. But that's kind of, now I feel like I'm rambling, but that's the story of kind of where Azul origin originally came from, my journey into it.
Wow, really interesting story. I did not expect this. What does it have to do? I mean, I'm pretty sure that it has everything to do, right? But how can you explain the injection molding?
Well, so injection molding, jumping over to that, is where traditional manufacturing, there's a couple different ways you can manufacture parts today. There's the subtractive method, which is you take a block of plastic, steel, whatever you want to start with, and you carve it out with a machine. So that's considered CNC milling, those different areas there. And then you have different methods where you start with a mold, injection molding, thermoforming, all these methods. You start with a mold that you then are putting material into that fills that mold and fills the spot. So that's where traditional manufacturing really lies, is those two combinations. Additive manufacturing, which is where we're moving into, is can we be trying to take a different part of the market, add different value. And how it works is that you start, for our system, we use liquid resins. And so you have basically a giant aquarium filled with liquid that light shines from underneath, and it shines as a projector, a 2D image. And that 2D image turns the liquid from a liquid to a solid. And then that starts to move up. And as that moves up, another image is shined, and you effectively are rolling a movie as this pulls up. So you go from a liquid vat to the easiest description. Have you ever seen, I think it's Terminator 2, where that pool turns into the Terminator? It's effectively something, it actually looks and feels a little bit like that, where the movie rolls and the part just comes out. The advantage here is that you don't have the same limitations that you do with other manufacturing. You can do more complex geometries, and the more intricate you get, actually the easier it is usually to print, which is the complete opposite of traditional manufacturing. With techniques like injection molding, the more complicated, the more expensive that mold gets, and so the more expensive your part is. And so there's a lot of new possibilities that open up.
Wow. And I mean, this is probably going to be a super dumb question, but how long does it take? Like, what is the main difference from 3D printing than the other manufacturing processes?
Yeah, so when you start thinking about it, traditional injection molding is amazingly fast, but when you start looking at other 3D printing, what we find is that we can be, 1,000 times faster than traditional 3D printers. And the reason for that is that the original invention that we did on that nanoscale was a method of how do you print continue? How do you have that pool just slowly pull out with never stopping? Traditionally, 3D printing was what they call layer by layer, where you make a single layer at a time. But when we talk about that vat, it would stick to the bottom of the vat. You'd have to peel it off, come back down, restart the chemistry, and go up again and do one layer. And these layers are incredibly thin. We're talking about something a third to the thickness of a hair at a time is how people. So we're talking about, just imagine one at a time, and a very good printer would do a centimeter per hour. And so if you want to print something that is this tall, you're talking about days to print. So what we're trying to do is, can we reduce that to, hours or minutes to be able to print? But that's really where the core of our technology started off as.
Wow. And I mean, I know that it's a startup, everything's new, even though 3D printing is not a new concept for most of the people. Still, I'm pretty sure that it's really hard to get customers, especially being a startup and founding your own company. So how was that process like, and what kind of customers do you have nowadays?
Yeah, the interesting about 3D printing, you're right, people forget it's 40 years old already from the original companies coming out. And it's because originally it was called rapid prototyping. It's great for making parts. And then the concept of additive manufacturing came in over time, but the technology hasn't been there. And the issue we find with customers is that these big companies said, hey, we're ready for manufacturing. They sold them the printer, and then the printer didn't do manufacturing. Oh. And so that's the biggest hurdle that we have, is not that they don't believe that additive manufacturing will get there. They just don't want to get burned twice trying to get there. It's been, I'll give you the story with one of our flagship customers of how our first customer we brought on, and this is talking about true startup time. We were about 6 people at the time, and it was a cold LinkedIn email that I messaged someone and bugged them enough, and then they finally took a call, and it ended up being Wilson Sporting Goods. And so they're in Chicago, and we're now starting to make a product with them for pickleball. So I don't know if you've ever heard of pickleball, but
go ahead, you can share the whole story.
Yeah. It's the fastest growing sport in the US right now. And it's something where we're now taking 5 parts and producing as a single piece. So you're taking 2 balsa wood handles, 2 carbon fiber faces, and a polypropylene core that are all now a single 3D printed part that gives you a new geometry that can help customize the sweet spot if you want. So if you think about the easiest thing is tennis rather than pickleball, if you play tennis, you know that the center usually plays better than the outside. What if you could change the geometry and the tension with it? With pickleball, you can't today, but now with 3D printing, you could. The other thing that we do is that there's a big issue around sound. And so we've actually, one of the paddles that they're going to market with is called the quiet paddle, because it dramatically changes the noise. If you look at, just search pickleball lawsuits, and you'll be shocked of how many different things they cross. I think 3 weeks ago, the front page of the New York Times was around this exact problem that's going across the country right now, because it really became the pandemic sport. And when it's 80 decibels for every hit, it's the equivalent of a freight train by your ear, and it's perfect for going through walls. And so these are one of these, but I will never forget the first time I met with them, because they came in. I thought I was going to get a 20-minute pitch. They let me pitch in front of the whole innovation team. And the first thing they handed me was a list of, here's the 30 companies we've already talked to see about getting this project. Why are you different than them? And a couple years later, and we're still working with them, and now we're starting to scale up. It's been a fun journey, but those are the type of things you have to get through. And it's, as if you're doing a startup and you have to, believe in what you have, and then show that belief to your customers, because that's the way they're going to believe.
Wow. And did you ever imagine being at this point of your life?
It's been interesting. I would have never guessed that this is the route I would have gone. But I couldn't imagine anything else doing now. Like what I say, the whole reason I did a PhD was because I was not ready to do a real job. I was like, I'm not ready for school. I'm going to push it off. Go do a PhD because that feels safe, because school has been, fun already. ish.
Let's just keep
So
going.
why don't keep doing it? It's easier than making a decision. And then Azul kind of happened into my lap. But the day to day of how much you have to do with a startup, because as a founder, as product, I'm in a mix of, and why I chose product versus more of the traditional science officer, technology officer, is I love the combination of being able to meet with customers and seeing the interesting thing about having a printer technology like ours is it's a base platform. The truth is that the solution we're offering is that part that comes off the printer. And so I get to work with customers to help them design and look at new parts coming off the printer while still trying to help the roadmap of what printers are going to keep building up from there. And then there's a whole other aspect of, as a startup, you have to be raising funds all the time. And so there's a whole another third of my job that is just purely how do you get the investors in that help keep going and aren't just money in the door, but add value to the company to take you to that next stage.
Totally. I was just about to ask you about the investors. How was the first experience, like your very first raw experience of getting the first investor into your project?
It was kind of wild. It was kind of crazy. So we did an angel round in 2017. The one thing I got really lucky and is that Shad, my co-founder, who's the chairman, we're startup number 8 for him, and so he has been through a number of startups. He's had a couple go public that have all come out of his lab. We're very different than the rest. All of his are nanotechnology, mostly in the medical field. So it was a very big jump to be going into manufacturing and hardware and building up like that. But having that access gave us access to some really great investors that, we still had to do these meetings. He was able to get us in the door, but you still had to close the deal. You still had to push everything through. But that first set of initial investors, I will always remember those pitches because they weren't easy. They dug into everything. They were long days with it, but they were now the investors that we brought in from it are people I still give regular calls to and talk to because their advice has just been amazing and completely needed for us to grow where we have.
Okay, we have talked about the good side of the company, about the hard times, but what about the challenges? Like, what would you say is the biggest technical challenge talking in the manufacturing that you have ever solved?
Ooh, there's so many technical challenges to go into that we've had to solve. The constant one we're facing right now is how do you think about supply chain as you start scaling up? We're starting to see a great demand. How do you get parts through the door? But on the tech, but that's more of an operations side. And it's actually something we're trying to solve as a company. The biggest challenge that I would say that the original printer, when I was talking about it, was around thermal management. And what I mean is that when these parts are made, they get incredibly hot. So when you go from liquid to solid, you're forming a bond and you're releasing heat to do that. And what we found is that something, maybe yay tall in about 10-minute print, we could do that and we could get 150 degrees Celsius temperature swing. So that's the equivalent of room temperature to fresh out of the oven. Well, we're printing with polymers, so plastic materials. Take that speaker you have right in front of you and go throw it in the oven for 20 minutes and see what happens.
Yeah. I don't know if I want to find out.
It's not going to end well. They warp, they bend. And what we found is that from my study, we kind of heard rumors that this heat problem was a problem. But when I did any research on it, I found out there's a paper in 1990 saying how big heat is a problem to go fast. And then there's 30 years of nothing until we eventually published our paper. And it's because it was such a hard problem. Everyone just swept it under the rug, didn't care about it, kept it secret. And that's something we keep finding in this industry is there's these really hard problems. People figured out that they existed and then they veered away from it.
Wow, but every company in the same industry has the same problem, but how do they manage to in order to solve it? They don't.
Yeah, well, when you start going and asking that, why isn't everyone going to manufacturing already? The problems for it to me is speed, size, and material properties. You have to have all three to be able to get to volume. The speed and size, if you can't go large and fast at the same time. And what we find is the really old technologies can go incredibly large, but again, Some of those can print a car bumper, but it takes 2 weeks to print a car bumper. No one wants a 2-week production time for a single piece. Now, on the other end, there's some printers that go really fast, but if they're only this big for the print area and you can only print, rings and maybe small trinkets, doesn't really matter. It's when you print large and fast does that heat buildup happen. And that is where we are the first time bridging that gap between size and speed.
Wow. Wow, really interesting. I had no idea. I mean, I don't know, COVID happened. Are there any critical challenges in the project development phase when it came to the procurement at that point?
Yeah, COVID was interesting for us. I definitely don't recommend trying to raise funds in March of 2020 with a close date 3 days before COVID hits, because that was probably the most exciting. Closing our Series A was definitely a fun one when we were all set and then everything fell apart and we had to rebuild it all up because, the whole world shut down and all the VCs we had just freaked out. But, you got through that. How we pivoted and really the area I want to focus on with COVID was we started manufacturing face shields. It was one of probably the highlight. The hours my team put in those first couple months was insane because we started doing 12-hour days where we found out each printer could do 1,000 face shields every 12 hours, which was about 10x times faster than the closest printer out there. So it gave us a great benchmark, but it also gave us a way to really help out. We even, of all things, had Johnny Galecki, who plays Leonard in Big Bang Theory, call us up and pay for the face shields so that we could donate them for free. So we covered the labor, he covered the cost for the materials, and then we were able to do this huge project of getting 10,000 face shields out over that summer, which was quite a feat for us to be able to really push through.
Wow. Last but not least, do you have any advice for future engineers or entrepreneurs starting on this path, on this really specific path of 3D printing?
For specific to 3D printing, it starts with following your passion part of it. So when you think about our company, we are a very interdisciplinary company. I have, people with math backgrounds, physics, but more of materials, chemistry, mechanical engineers, electrical engineers, chemical engineers. That's what I am. The range is pretty far because what we have is, you have people that are building, and software. I forgot that whole side. Like we have our own printer that we're building, and that is definitely heavy on the hardware side. Then when you have to be able to make your own materials, we found to be, because it was garbage in, garbage out when it came to the properties that came on that printer. So we had to develop our own material field, and then we had to develop the software to run it because this is automated chemistry. And if you're not running everything very precisely, you're not going to get consistent parts. And so with that, and then we have our fourth team on the R&D side, which is our application team. These are the people that are running the printer. They are heavy focused on CAD design and designing for additive because they help our customers think about, okay, here's our material properties, here's all the capabilities on design. How do we merge our materials and the design to make a part that you want? So there's a lot of very distinct areas in 3D printing, just even with us. And then we're one of many companies in 3D printing. I will say every 3D printing technology is very different. So with that, like the biggest thing is just following, like what part of that speaks to you? What is it that, do you like to program and think about the machine learning aspect that comes into these printers, or do you like to actually build the printer itself? Or are you more focused on what comes off that printer? And then once you figure out what is it that drives you, it's always what drives you, and then follow that passion all the way through. Like that's whether it's 3D printing or not, if you can't find that thing that's going to let you do those long night, like we used to call it Friday fun night here, where we would stay till 2 a.m. printing, because that's what everyone wanted to do to just get these parts off the ground and get the thing started. As we got bigger, we stopped that because not everyone wants their whole weekend to be just printing. But that is kind of, you have to find something that, you'd work all Friday night and then still call it a success.
A great Friday night.
Yeah, exactly.
Wow, really motivational. Thank you so much, James. And thank you so much for being here, for sharing your story with us. This is really interesting. I had no idea how 3D printing, your specific 3D printing technology was like. So thank you so much for sharing your story and your experiences. Do you have any social media? I know that you're on LinkedIn, but anything else?
I would say all of our social media for Azul is Azul 3D. For both, we have Instagram, we have Twitter. I think we even have a Facebook and a TikTok potentially starting.
Nice.
I'm not fully clued in on all of those right now, but yeah. And then I'm easiest to reach in on LinkedIn would be best for finding me. And I will say to anyone that is starting their own entrepreneurial journey, feel free to reach out. I'm always happy to talk to, people just starting out or people that need some advice to bounce off of.
This is great. I'm pretty sure that our audience appreciates that, especially all the engineers who are listening to us right now. So take note on that. And remember, guys, that you can also find more information, interesting articles like this one, or interviews also like this one directly on our website, controlhub.com/builder-nation. And we would love to hear from you. And once again, thank you so much, James, for sharing your story. I'm pretty sure this company will the success will keep coming.
Thank you so much.